Welcome back to the AI and You podcast. Today we're diving into the fascinating world of personalized recommendations, and specifically how Pinterest uses real-time user data to create a more engaging experience. Joining me are Shui Xia, a lead researcher at Pinterest, and field expert Name, a renowned expert in recommender systems. Shui, thanks for joining us.
It's great to be here. I'm excited to discuss our work on TransAct, a new approach to understanding and modeling user preferences in real time.
And your insights will be invaluable. Let's start with the big picture. Shui, why is real-time user action modeling so important for platforms like Pinterest?
Well, with billions of pins and over 400 million users, Pinterest has a massive amount of content and a constant flow of user activity. To keep users engaged, we need to understand their evolving interests and preferences, which can change rapidly. Real-time data helps us capture these short-term interests and respond quickly to user signals, leading to more relevant recommendations.
That makes perfect sense. How does this approach fit into the broader evolution of recommendation models?
Traditional recommender systems often relied on long-term user preferences, using historical data to create user profiles. But these systems often struggled to adapt to rapidly changing interests. Sequential recommendation models emerged to address this by incorporating user behavior over time, but they often face limitations with computational resources and latency. TransAct represents a significant advancement by focusing on real-time user activity while still considering longer-term interests. It's a clever blend of both worlds.
So Shui, tell us more about Pinterest's home feed ranking system, Pinnability. How does it work?
Pinnability is a multi-stage system that first retrieves a set of candidate pins based on user interests and other factors. Then, it ranks these pins using a pointwise multitask prediction model to estimate the likelihood of the user performing different actions on each pin. These actions could be clicks, repins, or even hiding a pin. Finally, a blending layer adjusts the ranked results to meet business requirements.
That's a complex system. How does TransAct integrate into this process?
TransAct is a key component within Pinnability. It's specifically designed to handle the real-time user action sequence feature. We collect each user's most recent 100 actions, including the timestamp, action type like click, repin, or hide, and the pin's content information. TransAct then analyzes this sequence to understand the user's immediate preferences.
That's fascinating. Could you dive deeper into the technical details of TransAct? How does it actually encode and process this real-time user action data?
TransAct uses a transformer-based architecture, a powerful approach that's been very successful in natural language processing. It first encodes the user actions into a sequence of embeddings, considering both the action type and the pin's content information. It then applies a transformer encoder with multiple layers to capture the relationships and dependencies within the sequence. Think of it like learning the grammar and context of the user's recent actions. This enables the model to understand not just what the user did, but why they did it.
And what about the early fusion step? How does TransAct connect the candidate pin to the user's past actions?
TransAct employs an early fusion technique called concatenation. For each action in the user's sequence, we combine the candidate pin's information with the action features. This allows the model to directly learn the relationship between the candidate pin and each pin the user has engaged with recently. It's like creating a richer context for the model to make its predictions.
That's very clever. I can see how this would lead to more accurate recommendations. But what about the issue of diversity? How does TransAct prevent the system from recommending only similar content based on recent actions?
That's a real challenge. We use a random time window mask during training. It randomly filters out certain actions within a given time window. This prevents the model from becoming too focused on the very most recent actions and encourages it to consider a broader range of the user's interests.
That's a very elegant solution. Shui, let's discuss the results. Can you walk us through the offline experiments and what they revealed about TransAct's performance?
We conducted extensive offline evaluations using a data set of 3 weeks of Pinterest home feed view logs. The model was trained on the first 2 weeks and evaluated on the third. We compared TransAct with several baseline models, including a wide and deep model, which incorporated the user sequence features as wide features, and Alibaba's Behavior Sequence Transformer, BST.
And what were the key findings? How did TransAct measure up to those baselines?
TransAct significantly outperformed the baselines, especially in terms of predicting negative actions like hide. It showed an improvement in hit at 3 repin, meaning users were more likely to repin relevant content. The ablation study also confirmed that TransAct was a critical component of the hybrid model, significantly contributing to overall performance. It demonstrated the value of real-time data in capturing short-term user interests.
Wow, those are very strong results. From your experience, what makes these findings so significant for the field of recommender systems?
This research highlights the critical importance of real-time data for personalized recommendations. TransAct's ability to capture evolving user interests in real time represents a significant step forward. This approach could be transformative for other platforms struggling to keep up with dynamic user behavior. It's a powerful demonstration of how AI can be used to create more engaging and personalized experiences.
Shui, let's talk about the online A/B experiment. What were the key metrics you were tracking, and what were the results of deploying TransAct on real users?
We measured home feed repin volume, which is a strong indicator of user engagement, and home feed hide volume, which reflects the proportion of irrelevant content. We observed a significant increase in repin volume and a decrease in hide volume. This means users were finding more relevant content and engaging more with the platform. We also saw an overall increase in time spent on Pinterest, which is another positive indicator of user satisfaction.
That's incredible. However, you mentioned facing some challenges in the online environment. Can you tell us more about those and the solutions you implemented?
Yes, one challenge was engagement decay. Because TransAct is so sensitive to real-time changes in user behavior, we found that the model's performance would gradually decrease over time without regular retraining. We addressed this by retraining the model twice a week, which helped maintain a stable engagement rate.
Makes sense. And what about the diversity issue?
We observed a slight drop in diversity as the model became focused on users' most recent actions. To address this, we implemented the random time window mask, which encouraged the model to consider a wider range of user interests. This effectively brought the diversity metric back to an acceptable level without compromising engagement.
Very interesting. Any thoughts on the implications of these findings for the broader recommender systems landscape?
This research clearly demonstrates the potential of real-time data in enhancing personalized recommendations. The results suggest that platforms should move beyond traditional static user profiles and embrace real-time user behavior. TransAct offers a compelling framework for doing so effectively. It's a blueprint for building more intelligent and responsive recommendation systems that can adapt to the ever-changing needs of users.
Shui, what are some of the limitations of this study, and what are your plans for future research?
While TransAct has proven highly effective, it's important to acknowledge its limitations. One is the potential for biases in the training data. We're exploring ways to mitigate these biases and ensure a more representative representation of user behavior. We also need to consider how to scale TransAct to handle even larger data sets. Future research will focus on exploring more advanced transformer architectures, further optimizing for efficiency, and investigating the impact of TransAct in diverse recommendation system contexts.
Great points. And any final thoughts on the broader impact and significance of this work?
I believe this research is a game changer for the future of personalized recommendations. TransAct has shown that real-time data can be leveraged to create a more engaging and personalized user experience, which is vital for businesses across all industries. It sets a new standard for how we understand and interact with users in the digital age.
Thank you both for this incredibly insightful conversation. Shui, it's clear that TransAct represents a significant advancement in the field of personalized recommendations, and its potential impact is vast. Your insights have been invaluable. For our listeners, remember that this research highlights the increasing importance of real-time data and AI in shaping how we interact with the digital world. Stay tuned for more exciting advancements in this area.